Assalamualaikum warahmatullahi wabarakatuh. Today I will do short presentation on our assignment 1 EPO510 from group CEEE2235A. My name is Muhammad Izwan bin Muhammad Ramzi and my group mate is Siti Ainan Najwa binti Muhammad Idwan. Our assignment is about 6-pass full bridge fully controlled rectifier with purely resistive load. In this assignment, we need to use the PSIM simulation to verify our manual calculation for continuous condition and discontinuous condition. The PSIM software version we use is 11.0.3.1.232x86/x64. For continuous condition of firing angle equal to 40 degree, our schematic diagram has 3-phase power supply of 415 volt with frequency of 50 Hz, 3 voltage probe connecting to each line of the 3-phase power supply, 1 voltage probe connecting to the both ends of resistor load, 1 current probe connecting to the one end of resistor load, 6 thyristors with 6 gating blocks connecting to each other, and 1 resistor load of 10 ohms. Now, I will focus on the gating block switching point angle. On T1, we start with 70 degree and 190 degree, which are 30 degree plus 40 degree and 150 degree plus 40 degree. The switching point angle is 120 degree apart from each other. On the next T2, the switching point angle is between thyristor is 60 degree apart. Therefore, it continues with 130 degree and 250 degree, where it is a 90 degree plus 40 degree and 210 degree plus 40 degree. This repeats for all the next thyristors and gating block switching point angle. When I run the simulation, we need to choose our voltage waveform and I proceed with the output voltage. It follows a sinusoidal wave shape, but when it reaches the firing angle of 40 degree, the output voltage goes up and repeats the same pattern for the next pulse. From the simulation, we got the average output voltage of 429.3892 volt and the RMS output voltage 443.8532 volt. Next, I will show you the whole vid I ran the simulation.
In this circuit, each thyristor is fired with a delay of 90 degree from its natural conduction point. For example, T1 would normally conduct at 30 degree, but with alpha is 90 degree, it is triggered at 120 degree. The same 90 degree delay is applied to all other thyristors, so T2 is fired at 180 degree instead of 90 degree, T3 at 240 degree instead of 150 degree, and so on. In this way, each device follows the sequence of conduction, but shifted forward by 90 degree. For the output voltage waveform, V out over time, the waveform is periodic, repeating every 20 milliseconds, which matches the 50 Hz input frequency. We can see a series of triangular pulses with peaks reaching slightly above 300 volt and dropping close to zero. This shape reflects the discontinuous conduction caused by the 90 degree firing delay. The sharp rise and fall in each pulse show when a new thyristor pair begins conducting, and the flat regions near zero show the non-conducting intervals where no thyristor is active. The value of average output voltage Vout that we get from the simulation is 74.646 volt, and the RMS output voltage is 121.5284 volt. Next, I will show you the simulation of PSIM simulation when the alpha is 90 degree.